Okay, so I got a flat bar. It is a thickness of 3 millimeters. It's got a hole drilled in it. Okay, width of the bar is 35 millimeters. Okay, and I want to figure out what the maximum load is so this thing doesn't fail. So we're getting a stress concentration right around that hole. Okay, where things kind of go up, and it's based on that graph that I have right there. So I'm going to find K. Okay, and then from K I find that sigma max over sigma average. This is how we deal with the stress concentrations, because we just used, force over area to find the sigma average, but then again, there's kind of a concentration around, sharp corners and things of that nature. So for this one, we use sigma max to be that allowable load of 50 megapascals. We don't want it to go any more than that, right? Okay, so I need to find what K is now, right? And you can see I need to find 2R over W in order to kind of determine what K is, right? So 2R, where 2R is basically the diameter, so it's 9 over 2 times 2, so that's just going to be 9, right? And then W is the width of this, which is 35, which gives me this value to be 0.257. Okay, so I come over here, and 0.257, that's 22426. It's right about here. Okay, where I'm going to call K, then what would that be? I'll call it 2.37 for my value here. Okay, so if I'm going to use K equals 2.37, I just now need to figure out sigma average, and again, that's given, right here, right? So sigma average is given by that equation right there, where again P is what I'm trying to find. W is 35 millimeters, so I'll go 0.035 meters minus 2R, which is, oops, get rid of that. 0.0099 millimeters times the thickness, which is 3 millimeters. Okay. All over P. And what that really is that's essentially this area right here, right? That smallest area that goes through right by that hole, right? That's the area that we're looking on here for sigma average. Okay, and that's where that equation basically comes from. Okay, so from that, I find that sigma average is 12,821 P. Okay, using all this, plugging it into that K equation, I say, okay, 2.37 equals 50 times 10 to the 6, that's megapascals, and then 12,821 P, and then from that I can determine that P is 1646 newtons. So again, on what's going on here is there's a stress concentration around that hole, and we use this graph to help figure out how big of a stress concentration that is, so that we can design it so that the P does not exceed that maximum stress around that stress concentration.